All right, thanks everyone for coming. I want to first off start by saying what an honor it is to be here speaking at Black Hat. I was reminiscing with Jeff Moss earlier today about how when I first got started with computer security, I watched the David Litchfield talk at Black Hat. And this is quite a while back. And I just remember thinking, you know, if I ever speak at Black Hat, I'll know I made it. Here I am speaking at Black Hat for the second time. In the next room over is David Litchfield talking about Oracle Ponage. And here we are. So it's a real honor to be here and to have a good-sized audience, even speaking with someone like David Litchfield next door. So appreciate it. We're here today to talk about URI use and abuse. As Travis mentioned, this is something that we've talked about a bit in the past. There is new information we're going to present. And the whole thing here is this has been about a year's worth of research. So there's a lot of stuff going into this, and it's going to continue to be a big issue, I think, over the next couple years. It really kind of strikes me as sort of like the file format flaws that really started to get uncovered by, you know, iDefense and various other people over the last couple years, and how much this class of vulnerabilities turned into just numerous exploits out in the wild on numerous different systems. This type of research kind of strikes me as very similar in that respect. The contributing authors for this research are myself. I'm Nathan McFeters. I'm a senior security analyst with Ernst & Young's Advanced Security Center, and I'm currently based out of Chicago. So if you're ever up in that area, look me up and go out and have a good time. Billy Kim Rios, who couldn't be here to speak with us today, but he actually just spoke earlier. I'm sure you guys saw him with the phishing talk with Nitesh, and that was an awesome talk. So it's a lot to follow that up. But he was the other primary contributing researcher to most of this work. And then Rob Carter, a good friend of mine from Ernst & Young's Advanced Security Center, and he's based out of Houston. He's helped us out with a ton of the actual exploitation of some of these issues. So that's the primary authors involved in this, giving credit where it's due since Billy couldn't join us. So I'm sure most of you are aware of what URIs are. A bit of an overview, I'm sure everybody's familiar with the generic URIs. HTTP, HTTPS, Telnet, Mail2, these types of things you see every day as you're moving around the internet. What are some of the other things that are registered URIs or protocol handlers on your system that you may not be aware about? I've listed some of those there: AIM, Firefox URL, Picasa, ITMS. These are all protocol handlers that are installed on your system if you have certain software installed. So the AIM URI handler is associated with Trillion Chat client in this case. The Firefox URL is associated with the Firefox browser. Picasa, obviously associated with Google's Picasa photo editing suite. ITMS is actually from iTunes. And what we found is through our research, there's so many applications that you install on your system every day, and you don't realize that there's these URI handlers that are getting registered in your operating system to interact with those applications. So now some of you are probably asking, okay, big deal, what does that mean to me? Well, URIs are able to interact with browsers, right? Obviously, we're all familiar with that. HTTP is the common URI you use to go to any web page. But actually, every URI that's registered on your system can be interacted with through Internet Explorer, and in many cases, many of the other browsers that you might put on your system. Obviously, I'm speaking in a Windows environment. As you'll see later, the same applies to other operating systems. So in this case, what's really going on here is developers have created URI hooks into their applications. So when Google created Picasa, someone decided, I think it'd be a really great idea if we could have a Picasa URI, and we could send that certain URI strings, and then that'd interact with our application in some way, and we could do some cool stuff, right? Once they're registered, like I said, they can be interacted with through the browser. So what does this mean to an attacker? Well, cross-site scripting, cross-site request forgery, malicious web pages, anything of this nature, even just phishing emails. You can send these links and thereby force a user to click these URIs that are going to interact with their operating system or with their applications. So it's a new attack vector for us from a cross-site scripting standpoint, or from many of the other common web application standpoints. So, discovery of these, how this came about, how we got to where we are now, right? This all really started when Billy Rios was up late one night eating a peanut butter and jelly sandwich like he usually is after a solid night of drinking. And, you know, we're talking on a chat, and he actually found this res URI. It's the actual resource URI handler for Microsoft Windows. And of course, you know, Rios is probably the shadiest guy I've ever met in my entire life. And the way he described finding it was that the peanut butter and jelly sandwich, some of it spilled out onto his keyboard, and literally typed res:// and hit enter on his browser. I don't believe that's actually true, but you'll never know, right? Well, after he found this, we got interested. We're like, well, I wonder what that thing does. And we'll cover what it does more later. But needless to say, we found this new URI that we weren't familiar with. I would say a few days later, I was in a situation where I was getting prepared to take the MCPD exam, and I had a nice instance of getting my power shut off for no real good reason. And I had no power and had to go and print out my exam certificate so I could go take the exam. So I went to my little apartment complex's business center, and it's late, I've been studying all night, and I can't even think straight, and I'm typing stuff wrong, and I'm trying to print this thing out, and the stupid printer won't work. And the next thing I know, this help page comes up to tell me about how to use the printer. Great. It's really that bad now. I don't even know how to use a printer anymore. But I noticed that the URI that was in the Internet Explorer window for this help page was ms-its : some stuff. And it's at this point that I contacted Rios, and I was just, where are these things coming from? This is crazy. Like, I don't even know what these things do. And so initially it started with just Billy and I one night just trying brute force to find all of the different URIs we could find. And it was obviously met with mixed results that weren't so great. But we later did some research, discovered that there is an RFC that defines an IANA-maintained registry of URI schemes. There's also a W3C list that maintains quote-unquote retired schemes, which are not actually retired. They're still in use even on my brand new Windows Vista system and, and other things of that nature. So, and then we started to think about it more, and we thought, okay, let's be smart about this. Where does Windows keep everything? The registry. And so we were able to look through the registry and discover that there were certain registry keys that registered URI or protocol handlers on the system. Once we did this, and I know this is kind of hard to see, I'm sorry for that, it's about the best we could do. Once we did that, we knew certain strings we could look for within the registry to pull out the protocol handlers. So it was an easy step to create just a simple VB script that would enumerate the registry. And what you're looking at here is on the left-hand side in the first column, you're seeing all of the protocol handler names. On the far right side, the far right-hand column, you're actually seeing the programs and the command lines as these programs are run that Windows has associated with these protocol handlers. So for instance, if you take the top line, it says Acrobat is the URI handler. I know if it's difficult to read. The program that's registered to run Acrobat is my C:/program files / Adobe Reader / acroread32.exe. And if you notice right after it, there's a /u, and there's this %1 character in double quotes. What that's saying is it's going to take in the URI I pass with Acrobat : / whatever my data is I want to pass, and it's going to plug it into this command line option and run that from the command line, basically. Not exactly from the command line, but through a Windows API that allows something like that to happen. And so when we found this, we're like, wow, this is unbelievable. I can't believe that there's these protocol handlers and they're associated with these programs, and I can actually pass data to them. That's super scary. So attacking these URIs becomes the next logical step to what we're going to do. And like I said, these URIs link us to applications. Now think about this. If you were an attacker and you were going to attack someone's Picasa install, how are you going to do that? Does Picasa listen on any ports for you? Actually it does. We'll talk about that later, but that's a side story. But more importantly, there's several applications that do not. And how are you going to ever attack those as an attacker? Well, you're just not, unless you're local on that person's machine. Except for, because of these URI and protocol handlers, now we can. Now we have a path from the internet to actually interact with applications on someone's machine that we would never otherwise have access to. So it's very interesting. What we also discovered, as you'll see from the demonstration we give, a lot of these applications are vulnerable to the most remedial code flaws that are like 1990 code flaws, stuff that you would just not even expect to see in commercial or production applications. We're talking about stack overflows, command injections, at the just most basic level. And so it's quite interesting how that's been tied into this. And I think, again, I want to reiterate, these URIs can be accessed by cross-site scripting or cross-site request forgery or malicious web pages, or just even by just passing someone a link and confusing them. So this is a new internet-based attack method is how you can look at it. So the first demonstration I'm going to give you is a Stack Overflow that we discovered in Trillion. Trillion's a pretty popular AIM chat client. It can also interact with other chat client type programs, different chat protocols. We use it all the time at work, which is why it was on my machine and registered, and I started playing with it. As you can see, I've mentioned the AIM URI is associated with the Run DLL32 application. And what Run DLL32 is, it's a Windows internal program. It's going to kick off the DLL that's listed and then provide it the appropriate command line arguments that you can see there. Now the obvious one of interest to us is that one that contains the value %1. Because now we know, okay, that's where our data is going to go. So that's our attack vector, right? And we actually control that value through the AIM URI. So it's going to be aim : / whatever data we want to send, right? And what we found out later on is that this value is actually copied without bounds checking, and it leads to your classic Stack Overflow that people have seen for numerous years now. So to walk you through that, here's an example. Obviously it's a long string, and you can see that it is a URI. And so how you would pass this to a victim is maybe through like an iframe with the source tag set to this appropriate value. What happens when this is accessed by the victim, whether they click the link or whether iframe kicked it off for them or whatever it might have been, is it's going to cause a Stack Overflow. In my case, I'm like any good computer security researcher. I've got Ollie debug set up as just-in-time debugger. And so the first time I send this long string, Ollie debug kicks up and I'm like, oh, holy crap, what's going on? I was just completely not expecting it at all. It's one of those things where you type it and you know it's not going to work, but then it does, and then you're completely confused by it. And here's what happens. So Ollie debug kicks up, and you can actually see, of course I've massaged it now so that the string comes out with nice A's and B's and the pointer to the next SEH record and SE handler. But you can see I have control now of the stack, and you can see that if you have ever seen Litchfield's paper on XP Service Pack 2 exploitation, I now control the appropriate things that I need to actually cause a full Stack Overflow exploit on this. And so that's where, this is kind of, I think, the first major issue that we found, that we reported, and it's so simple. It's just a common Stack Overflow and such a simple exploitation vector. Now when you extend this to cross-site scripting, it's now, cross-site scripting is no longer just about stealing your cookies. And I think people have been talking that for a long time now. Grossman and Arsnake and different people have done talks about the dangers of cross-site scripting and other web application type flaws. For anyone who's still not buying in, you can't help but believe that now cross-site scripting, if it can lead to Stack Overflows, is a pretty serious issue. So the next issue I'm going to demo is actually a command injection. And if you looked at what we previously had, these URIs are tied to command line parameters and they're tied to commands. And it's a pretty common thing to think, oh, well, maybe I could inject some commands. It's not as straightforward as it would sound. Like if you took a look back at our original, if I can find it, you see the %1. You might think, oh, hey, if I just close off that double quote, throw in an ampersand, and kick off a new command of whatever I want to do. Not so much. It doesn't work just like that. The Windows API that interacts with this stuff actually has some protection to prevent you from doing that. However, what you can do, let me stay on that slide for a second. What you can do is you can actually close out of that parameter and inject a new command line parameter. So I can't inject a new command to run on the command line, but I can inject a new parameter. And so I think this is like kind of one of those flaws that we found that you just knew it wouldn't work, and then somehow you decided to test it anyways, and then it did work, and again you were kind of like baffled by how that could be possible. What we have here is, if you see right after the URL equals double quote %1 double quote, there's another parameter called INI. And everybody knows that INI files are like initialization files. There's config stuff in there, right? This one's a standard hard-coded config file that Trillion has set up so that when it gets called from a URI like this, it uses this INI file to do something. And initially, when I'm talking to Billy about this over chat, I'm thinking, hey, maybe we could just, force our own file in there that's got a ton of characters in it. Maybe it will cause a Stack Overflow, right? And then, of course, we're talking about, well, yeah, but that's kind of stupid because how are you going to force someone to put a file in that location? And, we're just laughing it off as like, well, I'm going to just look at it anyways. So I threw in this huge file just full of A characters, just complete huge amount, millions of A characters. And I ran it, and of course, nothing happened, and we just laughed about it. And later on in the night, I think Billy would IM me back, and he's just like, hey man, he's like, does it read from that file or does it write to that file? I'm like, come on, it doesn't write to the file. That's just crazy talk. Why would it do something like that? But then I was like curious. I was thinking maybe I could just put more A's in it would cause a Stack Overflow. So I go back and look at my file, and I noticed that my file has dropped from like several megabytes worth of A characters to like a couple bytes. I'm like, well, that's really strange. And what I realized is that later on, as I'm testing this more, the longer a string I put in the URL vector, the aim URI vector here, the bigger the file gets. And that's just absurd. And so I actually spend the time to go look at the file after I've done some of this, and I realized that it's actually got my data from the URI in this file. And now if you keep in mind that I can inject command line arguments, I can inject my own INI parameter and put it to wherever I want. So I control where the file will go, and I'm also writing my own arbitrary data to the file. That's insane, it's stupid. But here I am, and I'm like, whoa, this is crazy. So what I can do is I can write a file to the Windows startup folder that's a batch file that includes a command. And the next time you reboot your system, you're gonna get hit with something. And so I have a demonstration of that I'll show now. Actually, yeah, let me show you the string first, because this is pretty interesting. So here's the actual vector I used for the attack. So you can see there's the aim colon to start the URI. I'm putting in a space character, and then I'm actually saying this is what I want it to write into the file. So it's an ampersand, it's the location of the command executable, or actually in this case it's calc. So it could have been any command I wanted to run. In this case I just chose calc. It's innocuous. Someone gets their hands on this, they're not going to do anything serious with it. And you can see that after that, I'm closing off the first argument, which is the URL argument, with the %22, that's a double quote in encoded form. And I'm saying add a new parameter called INI, and make it this location. See documents and settings, all users, start menu, program start, tone.bat. So I'm writing a batch file to the startup folder, so next time your program starts, it's going to run whatever's in this file, whether it's cruft or actually legitimate executable code. And so we'll show the demo here of that. Which one is it? Okay. So this is Billy's blog. I used to post on this with him. I'm showing you right now, this folder is that startup folder, and what I'm trying to show you is that there's no files currently in here. I'm like the magician trying to show you there's nothing in the hat. Just pretend there's nothing in the hat here. Now what I'm going to do is I've actually clicked the link that causes this exploit, I believe, or I'm bringing up the page that shows the exploit, one of the two. Yeah, I'm bringing up the page where our exploit code is put in, and I'm going to click the link, and at that point that command injection string I just showed you is going to fire, which is happening right now. I'm going to go back to the folder, and what you're going to see is that now I have a batch file within that folder. Now, you've already saw the string that I used for this. It's just to kick off calc. And rather than restarting my computer, I'm just going to actually go ahead and double click it so that you can see. I'm showing you also, if I edit it now, you can see what's inside of the file. This video is so slow. I can't believe I made this so slow. 1 second here.
It's your computer.
Yeah, maybe it's your computer. Maybe you're getting attacked right now. So it's hard to see. It's extremely hard to see. Basically, our command line is in there. The ampersand that's calling the calc program, right? So that's our command injection vector. And if I double click this, even though there's other cruft in the beginning, calc kicks off. So obviously, I could run any command I wanted to. The next time you reboot your system, this command will fire in the context of the user that you've logged in as. So if you are one of those people who decides to log in as an administrative user, you have some real problems in this case. Or even without, you're still probably in a lot of trouble. So this just kind of shows you command injection through cross-site scripting. I can honestly say that when I got involved with computer security, I never thought I would ever hear anyone say anything like that. And then there it is. But it didn't really stop there. There was other flaws to discover. We went back to the res protocol that Billy had discovered with his peanut butter and jelly sandwich. And just a little bit of background on what res is. You may think you've never even heard of this res protocol. You have. You've seen it a lot, I'm sure. If you've ever been to a page that comes up with a 404 error, and there's that little fancy page that IE shows you to say, hey, we couldn't find this page, and there's that little fancy blue question mark. That blue question mark, that little image, That's actually pulled from a res file. And you can see that right there in the example. What we're basically doing is we're pulling a static piece of content, like HTML, images, XSL style sheets, different things like this, from a dynamically executable piece of code, a DLL, an executable, something of this nature, right? And that's the syntax we would use for it. Now, there's a different syntax you can use for this. You don't have to name the individual static resource you're trying to grab from the dynamic executable by a name. You can name it by a number. And that's what we're showing here in the first example. And what we ended up realizing is that if we pass certain values, we were actually coming up into situations where IE7 would crash. And we just thought it was the most absurd thing we'd ever thought. And we started taking a look into it more. And what it looked like to us at the time was it looked like an integer overflow. It looked like there was an integer wraparound that created some sort of issue that caused IE7 to crash. Now, Billy and I have, I think, good skills in a lot of different areas. I think diagnosing integer overflows was probably not one of our major skill sets. So we kind of passed it to Microsoft and said, this looks like an integer overflow, but we're not really sure. Later on, we've come to realize that it's actually not an integer overflow. It's an arbitrary free issue. So once we go over a certain number threshold, the value that we provide is going to actually arbitrarily be freed. So if you want to take a look into this exploit and develop some exploit code, I mean, there's been a lot of papers on, I think, how those kinds of things can happen. It's pretty cool to think of that kind of an issue through cross-site scripting. This is an example of Billy's also a good computer security researcher that always has Ollie debug set as the just-in-time debugger just in case. And you can see that this is catching the crash. And then later on, you can see we have a whole lot of Unicoded A characters within the stack. And we could basically provide a massive ton load of A characters, and they'd be all over the stack. So in terms of an exploit, you know, I'll leave that to someone else to uncover, but pretty serious issue. Microsoft patched it with MS07-035. So another issue, and these two issues that are going to come up here, the next two issues. They were pretty big issues. They had a lot of coverage in the media. It almost started a bit of a browser war between Firefox and IE over whose fault was it anyways. I think Rios and I have always been at the standpoint of it's everybody's fault. The issues that we're uncovering here are not just individual to the applications themselves. We found issues that are issues on the operating system level, which you'll see it's a huge mess right now. This particular issue, we're calling it cross-browser scripting. I mean, I think Rios and I just started making names up. It was fun. You know, cross-browser scripting, cross-app scripting. It sounds cool, so we'll go with that, you know. The basic issue here, Firefox and Netscape Navigator 9, they registered URIs to be compliant with Windows Vista, is what we were told. I have no idea what compliant with Windows Vista means, nor do I still understand why these are necessary, yet they're there. Basically, the idea was, if you were in IE, like IE7, and you type Firefox URL://www.google.com, IE would actually spawn an instance of Firefox through a Windows API, and then what would happen is Firefox would browse to google.com. I don't know why I'd ever need that feature, but it was there. And what we actually figured out was, again, there's a command injection issue here. So if you guys have ever looked at running Firefox from the command line, there's a ton of arguments that you can pass Firefox. One of the really cool ones is the -Chrome argument. If anybody's done anything with Chrome coding, you know that it's this massively dangerous JavaScript-like entity. And I don't know that there's anybody that really completely understands it, but basically we were able to write shellcode to a degree, the ability to actually execute arbitrary commands within Chrome. And so what we were able to do is, again, we couldn't inject a brand new command, but we could inject a command line argument. And so in this case, we injected a command line argument for -Chrome, and then we were able to force the -Chrome to run Chrome code that would spawn a command prompt and run an arbitrary command of our choosing. So I'm going to show you the string that we used to do this, and some of it's straightforward, some of it looks a little bit like black magic. If you want to ask about it, I think the person to ask is actually Billy after the fact. You can see here there's the Firefox URL. We're passing the value test. Basically the %22 is, again, it's a double quote, so we're closing out of the current argument. There's a space character, and now we're injecting -Chrome. And everything after that is the black magic code that's creating our capability to actually run an arbitrary command. And so if you have questions on that, I think, like I said, ask Rios after or something like that, or later tonight at the bar. It's not straightforward. So, but that's the example of what we're going to use. And I'm going to go ahead and show you, just a live video of this actually happening here. Let's see. So again, we're at the XS Sniper blog where we have all of our proof of concept code listed. You're going to go down, you click the link. Again, basically it's passing that through and the command injection's happening. And shortly you should see a command prompt pop up to demonstrate that even through cross-site scripting, command injection is possible. And there you go. And I think Billy typed a nice little message here for us. Ha 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 ha. Because what else can you think when you see something like this? So, back to the slides. So this was not really where it ended for command injections through browsers and through other vectors like this. And I think this is an important place to kind of distinguish the different attack vectors here. I've been referring to this as URI handlers issues because that's what it was to me. I think over time, as we've become more mature in our understanding of what it is, there's really two classes of exploits here. You have protocol handler issues and you have URI handler issues. And it's an important distinction to make. Everything up until now I've described are protocol handler issues. They're one-shot attack vectors. So a protocol handler is associated with an application. You can attack that application through the protocol handler. A URI handler issue is in a different class of vulnerability, and to me it's more of a dangerous exploit. A URI handler refers to, it's actually a flaw in the operating system trying to associate that URI handler with the command that it should run. And so the difference here is, and you'll see it clearly here, is that given certain URIs, multiple applications will have problems with command injections in this case. And so this was the case with this particular flaw that I'm going to describe now. Basically the way this worked, when you have like a mail to URI or different things of that nature, and you have a Windows XP system with IE7 installed. These are the conditions for this to work. And you pass that mail to parameter with a just completely bastardized string, like I'll show you soon. What happens is the program itself will call the Shell32 DLL API, right? And it's going to tell that API, I just got this URI, I need you to do something to help me execute it, to do whatever I'm supposed to do with it. Shell32 actually tries to communicate with whatever browser you have installed, IE6 or IE7, or whatever it might be on the Windows end of things, and tries to say, I just got this URI. Does this look like a valid URI to you? Now, IE6 would always respond with, yes, it looks good. IE7 was smart enough to say, okay, no, this one doesn't look good, and send the response back to Shell32 DLL to say, no, this is no good. Well, in that case, what Shell32 DLL would try to do is it'd say, oh, it's no good? Let me look at it. Oh, you know what? I think I can fix it. I know what it's supposed to do. It's supposed to do this. Unfortunately, it was not supposed to do that. And that's what we uncovered. I'm going to show you the strings first. You can see these are hugely bastardized strings. Basically, the blah.bat at the very end, I think, is really what's confusing Shell32.dll. Batch files are associated with command line access, right? So they're associated with the command prompt type program. Same thing if we used a .exe on the end would be the same result, or a .com on the end would be the same result. Basically, we're confusing Shell32.dll to run our arbitrary string that we want to run as opposed to what it should have been doing. And so I'm going to go ahead and show you a video demo of this. The other thing to note, if you look at the protocol handlers for each of these, the mail2, the NNTP, news, SNews, and telnet, these are pretty standard protocols that most people have on their systems. And actually, any application that was able to interact with these in this way was vulnerable. So we had Gecko-based browsers like Mozilla Firefox, Mozilla, SeaMonkey, all these different things, Netscape Navigator. Any Gecko-based like system, so Mozilla Thunderbird, the Camino suite for actually doing like Dreamweaver type HTML programming, other applications, Outlook was vulnerable to this. Adobe Acrobat Reader was vulnerable to this. In fact, I'll talk about it a little bit later. PDP from New Citizen created a proof of concept for that, and it actually turned into a virus later on down the road. So a pretty serious issue. And we'll go ahead and just show this running here. So here we are again. Oh, wow, that happened really fast. I think we were actually in the middle. Okay. Sorry about that. There we go. All right, so back on the blog, and we're going to go and check out our links for this. Basically, these are just hard-coded links that are going to do our command injections, and you see with each of them, we're spawning a calc process. So, I mean, obviously, you could not do calc. You could do something more damaging in this case. So, pretty interesting attack vector, and this was one that actually Windows has since patched, and so you're safe from this. But this was a really serious issue because, like I mentioned, it wasn't just one program, and basically any application that was developed that interacted with the operating system in this fashion was effectively vulnerable. And I'm sure there was other things that were vulnerable. I think the Miranda instant messaging program may have been vulnerable. There were several that came out once we actually released this originally to Secunia's site. So moving forward, like I said, when this first came about, there was a bit of browser war over whose fault was this. The thing I really like about what happened is that as people were kind of bantering back and forth about whose fault was it, the Mozilla team really stepped up and just said, you know what, like, it might not be our fault, but we're going to go ahead and fix it anyways. And the other cool thing about it was Windows did the same thing. In fact, the Shell 32 DLL thing, I'm almost certain it was not news to them when we gave it to them, just because of how quickly it was patched. I mean, it's a pretty serious issue with a lot of ramifications, and it's deep in the OS, so it's not like you could just blindly fix this and just move on. It was a pretty serious functionality change. And so the speed with which both teams affected this issue, I think they really go to speak to how good these security teams are getting at handling issues. So it's pretty cool. I'm going to bring up Rob to talk about our trust-based applet attack against Google's Picasa. We affectionately call it the teabag attack, and Rob will talk about this at length. This is probably, I think, one of the coolest attacks that I've ever seen. This took a lot of brain power from Billy Rios, who's back in the back, myself, and Rob, to really come up with a scenario for how are we going to attack this. And then actually, Rob did most of the implementation of the actual attack, and it was a pretty complex one. So try to follow along, because as it gets going, it's just going to get more confusing. So.
All right, so like Nate was saying earlier, Picasa is Google's, image sharing / photo album / image editing program that they have, and it's a really nice program. It has some really cool features. One of which obviously is a Picasa URI that it has, and this Picasa URI has a little bit of different things they can do, some different functionality, and one of those things is the import button functionality. So we decided to delve a little deeper on that. I guess as I go on, this is probably going to get a little bit convoluted as to how this exploit works, because it's taking a lot of different attack vectors and bringing them together for one exploit. So I'll try to clearly explain what's going on here. But so first what it's doing is it's got the import button functionality here after the Picasa : // and then you give it a URL parameter, which in this case is shadyshady.com/evilbutton.xml. So the button that it imports is in XML format, obviously. It's a description of a button. There are several fields in there that you can change to change the appearance of the button and what the button does when it's actually clicked. So the main gist of the whole attack is that if we can load a button into your Picasa instance, I mean, since then this has been, somewhat remediated by Google by adding more strenuous warnings when buttons are imported. But if we can get you to click on our button, we're going to be able to steal all your images and see, all those naughty pictures of, your girlfriend or, whoever. So, all right. So initially, this was the first plan. This is the Ghetto Whiteboard edition that we had up on the whiteboard in the Advanced Security Center in Houston. And if you look really closely here, you can see Nate's chicken scratch. Terrible handwriting. We got arrows going all over the place.
Yeah, notice all the arrows redirecting us to say that step was completely off base. We need to go back.
Yeah. So we need to come up with a little bit cleaner version of what was going on. So this is kind of simplified, but you can kind of get the gist of it. And like I said, I'll delve deeper into how the attack works. But we, as the attacker, we're represented up in the upper left-hand corner there by the Pwn star graphic. So we plant our cross-site scripting, whether it's persistent, reflected, doesn't matter, on some large website like a YouTube, MySpace, Facebook, LinkedIn, you know, someplace that gives us a target-rich environment to attack. So some victim goes out to one of these large sites, they get cross-site scripted, so then we load this Flash applet inside of Picasa. We do anti-DNS pinning. You know, we steal images. We have a cross-domain.xml file out on our attack server. We connect back and send all the images out there, and we have your pictures. So, all right. So first of all, I'm going to go through what this XML button file looks like. So, all the stuff, like all the tags on the outside, that's not really important. What you want to look at here are the label, the tooltip, and the action tags here. And so the label and the tooltip actually control the appearance of the button. And as you can see here, we have it saying critical update available, and the tooltip text is click to download critical update. So this can be anything you want, just whatever it takes to social engineer the user to click on that button. And in this case, we chose to make them think that there's some kind of security update they had to download so we could steal their images. And then inside of the action tag here, there's another one called param, and inside that is a value natemcfeters.com/pwn.py. So what actually happens here is when you click this button, Picasa will go out to natemcfeters.com/pwn.py. It'll send a request there, and then it'll start up its own instance of a browser inside Picasa and then display whatever comes back. So the real interesting thing is that when this button's clicked, Picasa spawns Internet Explorer inside of itself. And what it sends is, up here you can see the headers. There's nothing particularly fantastic about that. You can see, we fired up Burp and had all of our requests proxy through there to see what was going on. And so we set our proxy in Microsoft Internet Explorer, and that happened to be what Burp was using, or what Picasa was using, sorry. And so, like I said, there's nothing extraordinary going on here, but down in the content of the post is what we're really interested in. And all this stuff here is XML, and it's an RSS feed, basically. And the really interesting stuff here is inside that red box. I don't know if you can read it, but there are tags in there that say photo image source equals, and then http://localhost : some random port / some random directory / the image name. So this was another moment where Nate and I are looking at each other. We're seeing this and we're like, that can't really be what it looks like. It looks like there's a web server running on your local box that Picasa started up on some random port that increments fairly regularly every time you restart the program. So no, that can't be right. So we scanned our local box and found that port was indeed open, fired up a browser, and went to this address, and sure enough, it was an image from our photo album. So,
and to be fair, Picasa does start this only on the local loopback.
Right, it's only
not
accessible.
like if I'm on the internet, I can access that, which is what we were talking about earlier.
So that kind of throws a kink in the works for our exploit.
Of course, the URI, though, gives us a vector to actually communicate with the application, and as Rob will point out, there's some things we can do to actually make it communicate back to itself.
Okay, so there are a couple of different possibilities here for us to play around with. Since it's only accessible on the local loopback interface, we can't make some kind of request from the internet to the user's local machine and steal these images. We have to load some kind of client-side scripting language or applet or something like that. Our choices are Live Connect in Java or Flash or something like that. So Flash just seemed to be the easier choice at the time. So we chose it for 3 different reasons. Number one, at the time, I don't know if this has changed or not. I've been told that Adobe's patched this problem, but I haven't taken the time to see if their patch really works or if they have indeed patched it. but at the time it was vulnerable to DNS rebinding and anti-DNS pinging attacks. So that allows us to take NateMcFeters.com, where the Flash applet was downloaded from, rebind it to the local loopback address, and then the Flash applet has access to all these images that are residing on this local web server. So then, number two, that leads us to number two here.
Before we go too far, in case you weren't following completely, because Picasa has a built-in browser interface that we can control where it directs the request to, and because it will send this information that is useful to find out where the images are, and because it was running a local web server on the local loopback, we have all the steps we need to make Picasa communicate with itself, and then using Flash communicate back to us.
Right. So, all right. Number two, if we have a valid cross-domain.xml file on our attack server, we can then use Flash to connect back to our attack server. Since NateMcFeters.com is now bound to 127.0.0.1, it has to have a cross-domain.xml file out here on the attacker server, so that when it tries to connect back, the attacker server like, yeah, it's cool, you can connect to me, do whatever you want, connect with your socket class and stuff, which leads me to number three. As of ActionScript 3.0, we now have access to a socket class that can read and write raw binary data. So before this, all we had was an XML socket class, which could only read and write XML data. But now we can take those images that we've downloaded with the Flash applet, and then connect back to our attack server and send that binary data to a Perl script that's listening. It'll just reassemble it on the back end, and then we have your pictures. So hopefully that was pretty clear. I've got a video now that I'm going to show you guys. I'm going to kind of step through the attack here.
This video shows it much cleaner in case you guys are really still wondering what the heck we're talking about up here.
All right, so first of all, we're going to bring up our browser. And this is our web app, little tiny web app thing that we have out on our attacker server. And it says that no photos have been stolen and uploaded yet, so I mean there's nothing out here. Later on, we're going to refresh that page to see if it's changed. So then we're going to go over to our DynDNS tab here, and we're using DynDNS in this example just to illustrate how this anti-DNS pinging attack works. This can be fully automated so that whenever somebody gets owned, it'll just automatically change the IP address when they do an anti-DNS pinging attack. So, but for here, it's more easily illustrated how this attack happens. And this IP address in this DNS record here, it's pointing back to a server that we had at Nate's apartment where we were working on this stuff. It's not there anymore. I mean, so it doesn't matter. But
I don't even live there anymore, so don't try to attack it if you're upset with this presentation.
So then later on, we're going to change this IP address when the anti-DNS pinging attack is happening to 127.0.0.1. Flash is going to go back out and request a DNS record. It's going to get that local address, and then think NateMcFeters.com resides right on the computer that it's on. So I've written Perl scripts and Perl DNS servers and stuff that'll automate that kind of thing. So, and then here we have a command line on our attacker server, and we're just going to start a Perl script that's going to listen on port 1337 for any incoming connections, and that's going to be our images that are being transferred back. So right now I'm starting at Picasa. We've got our cross-site scripted attack going. We've got our little photo album here. Yeah.
Basically, we've already cross-site scripted the victim, so just imagine that you've been cross-site scripted, this new button just got added that says critical updates, and you're like, oh man, I need to get my critical security updates, I gotta get patched.
Right, yeah, in the lower right-hand corner there, you can see it says critical updates available. So, me as the uneducated user, I'm gonna go ahead and click on that. In a second. Alright, so what's happening here is it's going out to pwn.py, and then pwn.py is redirecting you to that Flash thing you just saw. I'm redoing the IP address for the anti-DNS pinging attack. And now what we do is we just wait. I'm just going to pause it here for a second because this up here, what you're seeing with the Picasa logo on it and everything, we've specifically crafted this to look exactly like something you might see out on the Picasa website. So this progress bar right here, that's not actually downloading anything. That's just connected to a timer. And it's designed It's just designed to keep the user there for as long as possible so we can do this anti-DNS ping attack, because it takes a couple seconds. And then, depending on how many images they may have hundreds or thousands of images, and we want to get them all. So it'll just keep, incrementing, progress for download number 1, 2, 3. It'll just keep incrementing, as long as the user just sits there. So this is just another social engineering aspect. So this is going to take a couple seconds here. As you can see, the progress bar is incrementing. And
It'll actually run forever.
yeah.
So some poor saps out there probably right now going, man, I wish those Picasa updates had finished.
Or it'll get up to 65,000, whatever, and wrap around back to 1. So now you can see that we're getting images uploaded back to our attacker server. And, I think there's 11 of them, or 12 of them, 0 through 11. And so it's just, taking that stuff from the local web server, downloading it, and then uploading it back to our attacker server using the raw binary sockets. So, we need proof of this, obviously, that this actually worked, that, we're not just getting miscellaneous connections from our Flash applet. So we're going to go back to our attacker server here, and we're going to refresh the page. And so now we have a link. So we're going to click on that link, and now we've got pictures. So that's then a little dropkick pwnage there. So that's how the Picasa attack works. Hopefully you guys, I explained that well enough. Because it's kind of, like I was saying, it's kind of a convoluted attack. But I'm going to hand this back over to Nate here, and he's going to finish it up for us.
So I think one of the important things to show with what we've been doing here, this is not like just one specific type of thing we're looking at. This is a target-rich environment with very dangerous attacks. What Rob just showed is a protocol handler issue that was application-specific, that was not your classic type of attack. It's not a Stack Overflow. It's not a command injection. We're not even executing arbitrary commands on your computer. So when I was originally reporting this and talking about this to people, I had a few people in the media, because this particular URI handler issue has got a ton of media attention, and I had some people call me and ask me, like, what's this Picasa thing all about? It's not even, I actually had one guy say, that's not even cool. And I think the first media guy I talked to that really understood it was Ryan Narain. And when you're explaining this to someone and you're like, I can steal literally all the images on your computer if you are using this software. And when you understand what that means, it's like, how many of us have pictures that we probably don't want everybody to see?
Yeah, it's just a huge invasion of privacy.
And the other thing to mention is that Picasa actually indexes. I got a couple guys with some smiles right now. They're thinking about their girlfriend's pictures. Picasa will actually index almost all of the images on your machine by default. So, I mean, it's not just the pictures you take with your camera, right? Also to consider, which we didn't really look at, we could probably steal video as well. So if you got those nice MPEGs or AVIs out there, we might have those as well. But this is an application-specific attack, and what's cool about this is that eventually the stack overflows, the format string issues, they're going to start to go away, because people are going to be like, I really want to do this URI handler, but I know that Nate guy's out there looking for those stack overflows still, so I better be careful, right? But the application abuse, like this, using an application for something it wasn't intended to do, that kind of stuff is going to be more difficult to go away, because when you consider what these protocol handlers are in the beginning, they're a design decision that probably does not need to be made. We were talking about it the other day, and I've talked about it with several people. I don't think that there's a single one of these protocol handlers that I've actually felt like there was a really good reason to have it. Some of them are kind of cool, like the one I'm going to show next is kind of useful, but I can't really think of any good reason why I need this on my machine. Like if I don't have this, this application is worthless to me. And so I think that's kind of one of the overriding factors with security now, is you have to start making design decisions that are more intelligent and determine when adding another piece of functionality is actually really worthwhile. So I already mentioned, this is just to show that we're not the only people doing stuff with this. Once this really started to get media attention, there was a ton of people that started looking into these issues. PDP being probably the primary guy there, had some really cool issues with Adobe Acrobat Reader, had some cool stuff with the Java jar protocol handler, Just, showing credit where credit's due, there's been a lot of good research on this. This one I'm going to kind of go over pretty quickly. It's kind of stupid, but it's kind of fun. I call it stupid IM tricks. So almost every IM client registers a protocol handler for whatever reason. I think it's so that when you have like your little blog page, you can put a little link like Nitesh has on his that says, click this link to contact me, and it will send a message, right? But this is what you're going to get. And so if you look at some of the URIs here I'm sending, what's interesting about this is that if I'm an attacker and I know you personally and I think your girlfriend's pretty hot, I might want to talk to your girlfriend without you knowing about it. And I might want to talk to your girlfriend as if I'm you. And I might want to say something like, you know what, I think we should break up. It's you, it's not me. And, maybe I want to extend that a little bit further because she's pretty hot. I might want to say, I think you'd be better off with Nate. He's a really nice guy and he's dead sexy. And of course your girlfriend already knows I'm dead sexy, but it doesn't hurt to reiterate the fact. So what you have here is this is an attack vector on numerous IM clients, and it's pretty stupid, but it can be kind of fun. Now, yeah, they're stupid, but imagine, again, when we talk about this issue, we're not talking about one-shot deals. And I'm throwing a persistent cross-site scripting on MySpace, and I want to hit 200,000 users in the next hour. So imagine a site like that that's just getting tons of traffic, maybe even millions of users in 1 hour. Say like YouTube, and I just include it with like the My New Haircut video, and everybody goes and watches it because it's so hilarious, right? And then everybody gets hit by my cross-site scripting, and next thing you know, every single person's IM client is sending out massive amounts of these messages because I'm just looping it in JavaScript iframes over and over and over for as long as your browser's alive. Now I have a distributed denial of service attack against the IM service providers that can never be tracked back to me because it's just a persistent cross-site scripting I planted on some web page somewhere with a made-up account, and there you go. And so it takes it from the stupid to the semi-serious pretty quickly. So we've done this talk a couple times now. I think we did it originally, we originally started to touch on some of these issues at last year's DEF CON. We talked about this at TourCon. We talked about it at Black Hat Japan. And each time, the research keeps building. There's more targets. Like I said, it's a very target-rich environment. One of the things that's been repeated to me by a lot of people in the media that have asked me about this is, I'm not so worried about it because I got Linux. Okay, well that makes you safe, right? And I think the reason they think that makes them safe is there's no registry in Linux, right? So there's no place to register these URI handlers, right? Wrong. Linux, just like anything else, has to have a place to keep configuration issues. And of course, developers for Linux also want to use URIs. Why? I don't know. I don't know why the Windows developers want to use them. But there must be a book out there somewhere that I haven't read that's like protocol handlers rock, and if you don't put one in your app, you're never going to sell a single app. So, it's in tons of applications, and right here is a simple bash script that we've created that uses the gconf tool. Gconf tool is something that's included with the GNOME desktop environment, and it allows you to actually do registry-like configuration entries. And you can see right here, this script will actually dump out all the protocol handlers for a NIC system that's running GNOME. Rob's been cool enough to actually extend it so that it will also include KDE. So if you guys like KDE better, it's there too. I don't really care to spend a lot of time on all of those. So if someone out there uses Enlightenment or whatever the heck else, Fluxbox, Blackbox, whatever, if you want to post some stuff about it, feel free to contact me or shoot it out yourself. There's so much research to do in this area that, if you all went away today, you could probably have 5 advisories within the next couple weeks. That's how much stuff is out there. The Linux stuff is relatively untapped. We've had almost no time. I mean, Billy, myself, Rob, we all have day jobs. As much as my boss likes watching us do these talks, there's not a whole lot of time in every day to do this research. So this is normally at 5 o'clock when I'm coming back from the bar and there's nothing else to do or whatever it might be, right? So here's some output from the Duff for Linux tool that shows you that this is indeed an issue even in the Linux environment. Same type of thing we saw with the Duff for Windows environment. Well, that was kind of old. That was what was coming next last time. Of course, I didn't really care about getting involved with Linux because I'm just kind of sick and tired of hearing people talk about how secure Macs are, and I had to jump into that area. I just moved to Chicago. I live real close to Michigan Ave, and there's this great Apple store there. And I think I was going down there every day for about 4 or 5 hours secretly every day during work time when I should have been doing my actual work, and just pretty much hanging around trying to figure out where Macs kept their URL handlers. Eventually I realized that like this poor salesman who kept coming over to ask if he could help me was not going to go away. And he asked me, can I help you with something? I'm like, maybe. Like, do you know where the Macs keep their protocol handlers? And he just looked at me like I was crazy. Then the security guard started circling around, so I thought maybe it's time I just go ahead and buy myself a MacBook as opposed to coming in here and trying to hack this one. So I went ahead and bought myself a MacBook, and I figured out that it's not so straightforward as writing a bash script. What was nice is there's a guy, great guy, Carl Lindbergh, I don't know if anybody knows him. He developed an app for the Mac called RC Default App. I was pretty blown away that URI handling issues have actually been a problem in the Mac for a long time. Far before I started doing my research, which we thought it was completely a brand new field. Actually, if you go back to the month of Apple bugs, which was back in 2007, Kevin and some of those guys reported tons of these issues. And so it's not a new thing, it's been a problem. But Carl was nice enough to develop a nice little command line version because I can't stand using his GUI configuration thing. Even though it's really sweet for a regular user, I wanted my command line so I could plug it in with a fuzzer and do all kinds of cool stuff. But he wrote that for us, and it actually already helped us uncover a bug on the Mac. This was actually the output from that tool. I'm not really going to spend much time with it. You've seen it. It looks familiar. Great. Is this the same slide? Did I just hit the up key? That was awesome. Okay. Anyways, this was actually just patched a couple days ago. So if there's any MacBook people out there, you're going to want to apply this patch because me and David and Tiller, who they're all presenting tomorrow on the D-Tray stuff. It's going to be a great talk. You guys should definitely check that out if you're interested, especially in Mac or Linux-based development for vulnerability research. But we were actually spending a ton of time at this last night at the bar, real close to having like a fully working exploit on this. So you might want to patch it. Because, you know, they've claimed they fixed it now, so I'm going to go ahead and release it. But this is a format string issue. I'm sure you guys are familiar with format string issues. They're nothing new. The interesting thing about this, a format string issue was already reported in iPhoto by Kevin and the Month of Apple Bugs guys. If you go to their Month of Apple Bugs site, there's a photo://%n, and that's like literally what they do to demo it. It causes iPhoto to crash. Basically with %n, that's a %n modifier, you're writing to some memory location, typically it's going to cause a seg fault or something like that that's going to cause the application to crash, right? Great proof of concept. They actually claim that theirs was not exploitable because it was a flaw in Core Foundation, which are Mac-based classes for doing several things. And Mac had actually purposely broke the %n modifier for format string functions within their Core Foundation classes. The nice thing is, after they fixed it, and after I was doing my own research and had no idea of what the Month of Apple Bugs was, I had actually had a typo in my format string flaw attempt. I wanted to do the same thing, photo://%n. Somehow I randomly typed %dd and then a %n. I have no idea why I typed this. I had this huge string of %n's and ended up whittling it down to saying this %dd, %n will cause the application to crash. Later on I found this issue and me and my friend were talking about it and we were like, I think this is already reported. But it wasn't, it's a different issue. This particular issue is actually in iPhoto itself, which means that even though Core Foundation is broken for this issue, this one appears to not be, which David and Tiller and I and Rob will hopefully find out shortly and actually have some working exploit code for. So just a real quick showing you how this works. Here is my instance of iPhoto. That's my beautiful girlfriend down in the bottom right-hand corner. There is a photo feed that I've clicked, photo:// some remote site, and when I click that, it's asking me to subscribe to that photo feed. If I push subscribe, this is what happens, format string flaw. This particular format string, I'm going to show you the strings later just in the interest of saving time. Basically what I've done is I've done a photo://%dd and then a bunch of %x's. So I'm popping stuff right off the stack and you can see addresses and different things within there. So very interesting, right? Next one was using it with %n, which is the %n modifier. So it's going to try to write to, you know, a place on the stack or somewhere in memory or wherever it might be. You can see here the thread is crashing, and actually if you look at it, it's the vfprintf function that's got the crash. That's where everything's crashing. And so This is actually probably extremely difficult to read, and this is what I was stuck with. Now I know I have a format string flaw, and how do you go about developing a exploit for it? You know, I don't know. GDB, it kind of sucks for vulnerability development. And just to be perfectly honest, I mean, I didn't really know where to go. I'm no GDB guru to try to go through this. If I'm on Windows and I got Ollie debug and WinDebug, I'm in my comfortable little world and everything's great and happy. As soon as I'm hit with GDB, I'm like, here is the next 5 instructions. I know that it's crashing on the move. I can see what's in the registers. That is where I stop. Great thing was, you know, I've had some free time being here for this week. It's almost like a little vacation. And I was like, you know, maybe I should look into this new thing, this dtrace, because this is supposed to be this new great debugger that's in the Mac, and maybe this will help me out. And I'm actually searching on Google for it, and I see this link come up, and it's on the Black Hat site. And it's about someone's presentation on how to make dtrace easy for vulnerability research. And so I'm freaking out, because I'm like, these guys are going to be here. And so I left messages for David and Tiller, and you know, I think we're going to get really close to actually getting an exploit. I'm going to show you a little bit about what we did last night. This is brand new slides, so if you look at the slide book, it's not in there. You'll see it when we get out the slides for the final thing. Basically, this is just an iframe that's going to kick off our photo URI handler, and it's going to actually cause the exploit to occur. It's hard to see. You can see the %DD there. These are a bunch of funky A characters that Tiller and David discovered that would do something magical. I'm not quite sure yet. The percent ends at the very end, and that's what's going to cause the arbitrary write.
Those funky A characters were supposed to be a NOP slide.
Okay, so it's a NOP slide.
We were messing around with.
Great, NOP slide. That's what it was. So this is actually showing David and Tiller's tool. They're using dtrace right now, and they're setting it up to actually work with. It's hard to see. One of the lines is saying, I want to track the vfprintf function. And basically, I want to find all instances of when it's called where the second argument passed to it is equal to %25n. How freaking cool is that? You know, when you're doing vulnerability research and it's like a vfprintf function that's going to get hit like all the time, you remember having to step through and count and like, it's like 25 in, and then once that's there, then my stuff's on the stack, right? And that's where I'm going to exploit it. You don't even mess with that anymore. This thing tells you exactly what's going on when. And so it was, you know, really great to use. Next slide is actually what we're doing here is we're dumping all of the memory and everything on the stack. So I think, actually, is this the heap or the stack that you're dumping here?
It's the entire process.
The entire process, dumping the entire process space. And then later on at the very bottom, you can see there's doing a search mem for the process for the address dead beef, which is obviously an easy thing to look for. And what we're doing there is we're actually searching for our attack string within the stack. I defy anybody but Kevin from the month of Apple Bugs to have something to do this. If you read his website, he has a GDB plugin that he wrote that he will not share with you. If he's out there and he wants to share with me, cool. But, you know, it's out there now. Yeah, we got this now. So, you know, here we go. And now you got the thing you need. I mean, you need to find where your stuff is in the stack to do any exploit, right? So, or where it is in memory. This is another example where it's actually searching, I think, within memory. And so this is actually on the heap. And you can see that down on the bottom, we're actually finding our string on the heap. And so this is giving us everything we need as an attack vector for the exploit now. So, you know, over the next couple days, maybe weeks, I think David and Tiller and I will be able to get a fully working exploit for this. So if any of you are at Black Hat Europe, hopefully we will get in for Black Hat Vegas. Maybe you'll see us there and we'll talk about it in more detail then. And then, you know, one last thing, I think we're kind of running probably overtime at this point. Oh, no, we're good? Oh, sweet. That's awesome. Okay, just in time for tax season. You know, like I said, I just got this Mac, and originally I bought it because I wanted to do research. And I gotta be honest with you, I've hated Macs for a long time. Ever since they came out with that hockey puck mouse that has like the one button click, you know what I'm talking about, right? You know what I'm talking about. That kind of a dumb decision, I just feel like they must have done something else stupid when they were building this machine. You know, and you know what? I bet a one-click mouse is actually much easier to use, and I'm just stuck in my ways, and I'm an old man now or something, but I gotta have my 2 buttons, man. I gotta have them. And so it took me forever to kind of jump on board with the Mac. Now after I bought it and was using it for research, I fucking love it. It's great. I want to use it every day. I want it to be my primary computer. So I go ahead and buy TurboTax, and I'm going to do my taxes because I'm just wanting to find out how much the government's going to kill me this year on taxes and how much I need to pay in, and it's great. And I go ahead and install it, and randomly I'm trying to get the slides together for Black Hat and find a nice screenshot of our Duffer Mac tool to show all of the URI handlers for the Mac. I'm like, what are these? These four URIs came out of nowhere. I wasn't even expecting them. I didn't know, I hadn't installed anything else but TurboTax, so I wasn't expecting anything new. And of course I'm like, what the hell are those for? I mean, that doesn't even make sense. Com.Intuit? What's that? And then I realized, oh, that's, I think, the company that makes TurboTax. And so I'm like, oh, that's interesting. Let me see what these do. Funny thing is, I had my tax return like all the way in process, and I'm getting ready to send it off. And this is right about the time I find this kind of randomly, because I'm trying to do several things at the same time. And I went ahead and did one of them, and it actually crashed TurboTax, and I had to start all over. So, look, we can debate denial of service attacks to the end of time. I was pissed. I was seriously pissed. If I had been cross-site scripted and this had happened, man, I probably just wouldn't have done my taxes this year. You know, but here you are, there's 4 of them. I don't have any idea why using one of them made it crash. Like I said, I didn't have a nice handy Ruby wrapper and all this cool stuff for dtrace until yesterday. So maybe I'll find out over the next couple of days and we'll see what happens. But obviously, you know, I can pass anything on that URI string that I want. So maybe, you know, my data will go on the stack somewhere, or maybe this is some sort of, you know, arbitrary free issue. Maybe there's something I can do with this. We'll just have to see. But I guess the point of the matter is, this is an ongoing problem. Why would TurboTax ever need to do this? I can't think of a reason that's good. But they're not alone. It seems like every application developer, every third party, they gotta have their little protocol handlers. I'm waiting to find that book, because I do a lot of development myself. I'm waiting to find that book that just says protocol handlers rock. You should have one. If you don't, your app sucks. But until I find it, I'm still going to wonder why these are necessary. What was really interesting is after I discovered this, I was just so curious, so I had to go buy the version for Windows Vista 2 and see if these are registered on Windows Vista, and they're in fact not. So I challenge you to explain to me why they would be necessary on one operating system and not the other. But that's probably an argument for the ages. I'm sure TurboTax will contact me at some point and want to know more about why I was talking about. Oh, that was the microphone. Sorry about that. Anyway, conclusions, any questions? We're very approachable guys. We love beautiful women, so anyone? No? Okay, that's cool. But if you have any questions, we're going to be outside at the speakers table for sure. So come talk to us. We can go over whatever. If there's any questions right now, I think I got a little bit of time. So if there's any questions right now, I can take some questions. No? Sweet.